We're going to go ahead and take a look at graphing rational functions. Basically, a rational function is a rational expression equal to f of x or y. Basically, you need to have variables on the bottom. Likely you'll have variables on the top, but you don't have to have variables on the top. So anything that has variables down here in the bottom of a fraction could have variables in the top, or it could be just a number equal to y is going to be referred to as a rational function. Now, there's several things you want to do in graphing a rational function. And you can see in the picture over here, the common things that show up with a rational function are horizontal asymptotes may show up, vertical asymptotes in red may show up, which are basically lines that your graph gets close to but never really touches. Now, can you touch a horizontal one? Yes. The horizontal really tells you what happens when you go far to the right and far to the left. You'll also notice you have a hole here, which is a spot that's just missing in your graph. So to go ahead and graph a rational function, you need to follow these bullet points. Factor the top and the bottom. Then you want to find your domain. Remember, you can never divide by 0, so basically you set the bottom equal to 0. That's going to be all real numbers except what causes the bottom to be equal to 0. So you'd write it out in a very similar way to what you see here. All real numbers except x cannot be equal to 2 or x cannot be equal to negative 5. A hole occurs when we have a common factor on the top and the bottom. You could have more than one hole, but if you have a common factor top and bottom, you have a hole. Now, vertical asymptotes occur when you still have variables in the bottom after you've crossed out that common factor top and bottom. And it's whatever sets that variable factor in the bottom equal to 0. And you could have more than one vertical asymptotes. Now, sometimes you have horizontal asymptotes, sometimes you don't. Typically, it's going to be a horizontal asymptote if you have a bigger power on the bottom or the same power top and bottom. Now, you'll only have one or no horizontal asymptotes. You will not have a horizontal asymptote when the power in the top is bigger. So talk a little bit more about having a horizontal asymptote or not. It's all related to the biggest power in the top and the biggest power in the bottom. So before you factor it, look at your biggest power in the top. We're going to call it n, and your biggest power in the bottom we're going to call m. And that's referred to as your degree, the highest exponent. Now, if the top has a smaller exponent than the bottom, that's our first if statement, then it's always a horizontal asymptote of 0. Lets you know when you go far to the right and far to the left, your graph will get close to a height of 0. Now, if the top and the bottom have the same power, that's our second bullet point, then it's just going to be what you get when you go y equals these two numbers in front of those highest powers divided by each other. Now, if the top has a bigger power than the bottom, there's no horizontal asymptote. There'll be an oblique or a slant asymptote, but we're not going to be real concerned about getting into that. So let's go ahead and go through all this process for this problem right here. So the first thing you'd want to do is to factor the top and the bottom. Well, in this case, it doesn't factor. And so then you'd want to find your domain. Now your domain is going to be all real numbers except x cannot be equal to, and you look at what causes the bottom to be 0. Well, if you set the bottom equal to 0, you just get x to be 0, and so that's going to be what we have here. Now, holes occur when you have a common factor top and bottom, of which we don't have anything top and bottom the same. So we have no holes, so I'm going to go holes, none. Vertical asymptotes occur at whatever causes the bottom to be 0. So I set the bottom equal to 0, solve it for x. Well, I get x to be equal to 0. Now, on the top, there's really, come on, there we go. It's really an x to the 0 power here, because remember, x to the 0 is 1, and 1 times 4 doesn't change it. And it's an x to the first in the bottom. So that's where, for horizontal asymptotes, you got to look at the power on the top and the power on the bottom. We have the top having a smaller exponent than the bottom, so we get y is equal to 0. So now I can go ahead and graph some of this stuff. Y is equal to 0 would be a dotted line going across here. My x equals 0 is my vertical asymptote. That would be a dotted line going up and down here. Have no holes, and I have my domain. Now, you want to now make an XY table, and you want to choose at least 3 numbers on any side of any hole or vertical asymptote. So I'm going to put my vertical asymptote down here of 0, which I'm going to write VA here. And I want to choose at least 3 numbers on each side. So I'm going to choose -1, -2, -3, -4. And I want to try at least 3 numbers on the other side. And then all we have to do is go ahead and plug in these x values into my original function. And so when I plug in -4, I get -4 over -4, which is 1. And some of these are going to end up being not nice numbers, so then I would go to the nearest tenth of a decimal point. So when I plug in -3, I get -1.3. Could we write it as a fraction? Yes. Could we go more decimal points? Yes. But you're graphing these, and it's harder to get even more accurate than the nearest tenth. Plug in -2, and I get out 2. Plug in -1 to my problem, and I get -4 over -1, which is +4. And then I'm going to plug in the numbers on the other side of my vertical asymptote. Plug in 4, plug in 2, plug in 3, plug in 4, and then I'm going to go ahead and plot my points. I'll start with the bottom one, 4 to the right, 1 down. Next one up, 3 to the right, down a little bit more than 1. 2 to the right, down 2. 1 to the right, down 4. Then I have my vertical asymptote. Then I go 1 to the left, up 4. 2 to the left, up 2. 3 to the left, up a little bit more than 1. And then 4 to the left, up 1. Now, when we go back here, vertical asymptotes, or not vertical asymptotes, rational functions often have these kind of purple sloping curved things. And you'll notice that's what we end up with here. So I'm going to go ahead and draw in a smooth curve connecting all these, getting close to my vertical asymptote, and then curving out, getting close to my horizontal asymptote. Same idea here. Now, just as a reminder, sometimes your graph can cross a horizontal asymptote in the middle of your graph, but not as you go far to the right and far to the left. You can never cross a vertical asymptote. Really, that's all we have to do on any of these. So we're going to start out by factoring the top and factoring the bottom. Now I'll get a x minus 3 and an x minus 1. I'll get an x plus 4 and an x minus 3. Now your domain is all real numbers except what causes the bottom to be 0. I set my first parenthesis equal to 0, x plus 4 equals 0, and solve that, and I get x to be equal to -4. Set my second parenthesis in the bottom to be equal to 0, and solve that, and I get x to be equal to 3. Then I want to see if I have any common factors top and bottom, which I do right here. So that means I have a hole. Set that common factor of an x minus 3 equal to 0 and solve it, and I'll get x to be equal to 3. So now I'm going to go ahead and write what I have left. I have no more holes in the simplified part, but I do have vertical asymptotes because vertical asymptotes occur in your simplified function when you have any variables left in the bottom. Set that x plus 4 equal to 0, and I would get an x to be equal to negative 4. Notice your holes in your vertical asymptotes match what you cannot use for your domain. You then want to go ahead and take a look at any highest powers to try to find horizontal asymptotes. Now, you'll notice on the top, our highest power is 2. Our highest power is 2. When the top and the bottom are the same, all it is just the number in front, which is a 1, over the number in front, which is 1, and 1 divided by 1 is 1, and that would be y is equal to 1. Any horizontal asymptote, sorry about that, it's a horizontal line, so it's always y equals. Vertical asymptotes are vertical lines, so those are always x equals. Then you want to go ahead and make yourself a table, an xy table. And you want to put in your vertical asymptotes and plug in your hole. And you want to try at least 3 numbers on any side of a vertical asymptote or hole. And then everything in between. Now, can you plug them into the original? Yes. I always prefer to plug them into my simplified one right here. So you can use your calculator, plug in -7 into that simplified one, and you would get 2.7. Plug in -6, you get 3.5. Plug in -5, you get 6. Once again, this is our vertical asymptote. And I'm going to label this one as our hole. And then just go ahead and plug all these numbers in. And then you want to go ahead and just graph all this. So first of all, I'm going to put in my vertical asymptote at -4. Put in my horizontal asymptote at y is equal to 1. And then I'm going to start plotting points. Left 7 up about 2.7. Left 6 up 3.5. Left 5 up 6. Then I have my vertical asymptote. Left 3 down 4. Left 2 down 1.5. Left 1 down just almost 1. Left and right 0 down 1/4. Left and right, or right 1 up 0. And then I have my hole once I do the next one here at 3, which we'll come back to in a bit. And then I have right 4 up almost a half. So now I'm going to go ahead and draw this in. I have my nice smooth curve here. I have my nice smooth curve here. But remember at 3 you have a hole, so basically you just leave a little open circle connecting both parts there for your hole. And that's how you graph rational functions. So here, we're going to do the same type of thing, but you'll notice it says you don't need to graph. I'm going to go ahead and factor the top. I'm going to factor the bottom. So I'm going to look at my domain. It's going to be all real numbers, except what causes the bottom to be 0. You set the first one equal to 0. X minus 3 equal to 0. Solve that for x, and you get 3. And then you can set your negative 3x equal to 0, and you solve it for x, and you get x is equal to 0. So those are the numbers you cannot use other than all real numbers, except those. Now, wholes occur when you have any common factors, top and bottom. And that would be an x times the top and an x times the bottom. So you set that common factor equal to 0, and you get x is equal to 0. Now, I'm going to look at what's left for the simplified version. That works well for finding the other things. Then we can find our vertical asymptotes, and that happens when the bottom is equal to 0. So I'm going to take the part with the variables in it, set it equal to 0, x minus 3 is equal to 0, solve that, and I get an x is equal to 3. Now, if we are looking at um, horizontal asymptotes, so horizontal asymptotes, you'll notice we have the same power top and bottom. So we know it's going to be y is equal to a number. And you got to look at what's in front of your x's. We have a 1 here. We have a negative 3 here. So you take and divide those, that negative 1, on or that 1 on top over the negative 3 on the bottom, and that's your horizontal asymptote. Now, if you did need to go ahead and graph this, you'd make yourself a table, choosing at least 3 numbers on each side of any whole and vertical asymptote.